the first thing that I would do in this problem is get rid of my fraction. So in order to get rid of your fraction here, if you think of all of these in terms of fractions, I can multiply every single term by the LCD of every fraction involved. So there's only one factor in any denominator here, and that's root x. So what I'm going to do is I'm going to multiply every individual term on each side of the equation by root x. When I do that, I get 3 root x times root x is just x. Minus here, the root x cancel, so I'm left with the minus 4. And on the far right, there's nothing that cancels, so I do get 4 root x. Okay. Now, once I get to this point, I can choose one of two methods, right? Is my lesser power exactly half that of my greater power? So I can use u substitution here, right? So one possibility is to say we let u equal root x. If that's the case, then u squared is going to equal x, and I get my equation 3u squared minus 4 equals 4u. And I can solve as the quadratic type that this forms. Okay, so I could subtract a 4u from both sides. And now I can look to solve this. I'm going to see if I can have binomial factors here. So the way I see that is I test my leading coefficient times my constant. Gives me a product of negative 12. Are there two factors of negative 12 whose sum is this middle term's coefficient, negative 4? Yeah. So negative 6 and positive 2. So I can rewrite my middle term as those and drop my first and last terms down and factor by grouping. Removing a 3u from my first pair leaves a u minus 2. Removing a common factor of 2 from my second pair leaves a u minus 2. It worked out exactly as I was planning. I have a common binomial factor which I can take out, and the remaining factors form the terms of my other binomial, 3u and a plus 2. So I get two possible values for u. U can be 2 and u can be negative 2/3. Okay? So the final thing that I need to do here is I need to plug those back into my original. Okay, when I look at my original, u is equivalent to root x. So I'm going to say root x is equal to 2, and root x is equal to negative 2/3. Okay, when I solve this, it's a square root. So I undo the square root by squaring both sides. I get x is equal to 4. Okay, and here, do I even need to go any further? Is it possible for the square root of a number to equal a negative value? No. So I know that that's extraneous anyway. I'm not even going to test it. Okay, so now we check our solution to see if it works. 3 times root 4 is 2, minus 4 over root 4 of 2. Is that equal to 4? Is it true that 6 minus 2 is equal to 4? Yeah, and so that checks as your solution. Okay, now, I had mentioned that there was another way to solve this, right? So the other way that you could have solved this is from this form right here. We can solve it as a radical. So if we were going to solve this as a radical, so let me copy it. Okay, so the other alternative for this would have been to isolate our radical. It's already done. If we tried to divide by 4, we wind up with a fraction, so it's not even worth doing. Okay, so let's square both sides. If we square both sides, we square the 4, giving 16, and square the root x, giving an x. And on the right side here, we're going to perform the expansion rules for a binomial square. Square the first term, square the 3, square the x. Take the product of the terms and double it. So 3x times negative 4 is negative 12. Double that, you get negative 24x. And then square our last term, negative 4 squared is 16. Okay, so if this was the steps that we would take, we'd subtract 16x from both sides, giving us 9x squared minus 40x plus 16 is equal to 0. So you can already see that this winds up giving you a little bit harder to work with numbers. Okay? But if we were going to test and see, can we rewrite the middle term? And so if we look, 9 times 16, 9 times 10 is 90, 9 times 6 is 54, 54 plus 90 is 144. So are there two factors of 144 whose sum is negative 40? Well, we know that they would both have to be negatives. And it winds up being a little bit tougher to calculate these, but if you went through them, you'd get 36 and 4. So negative 36 and negative 4 are the two factors of positive 144 whose sum is minus 40x. Rewrite the middle term, drop the first and last terms down, and factor by grouping. So we can remove a common factor of 9x, leaving x minus 4. Remove a common factor of negative 4, leaving x minus 4. If that's the case, we get our common binomial factor. Inside, we get 9x minus 4. Set each of those equal to 0 and solve. And our two potential answers, x is positive 4 and x is 4/9. And if you test these into your original form, okay, 3 times 4 is 12, minus 4, is that equal to 4 times the square root of 4? Is 12 minus 4, 8, equal to 4 times 2, 8? Yeah, so 4 works. If we test 4/9, we get 3 times 4/9 minus 4. Is that equal to 4 times the square root of 4/9? Well, right here you can see that the 3 and the 9 cancel. 4/3 minus 4 is going to give us a negative number, right? There's no way that a negative number can equal 4 times the square root of a positive value. So we know that that's going to be extraneous.